Hi folks, I'm Florian from iProcess, and today we are talking about system-level regression testing and why it's such a critical contributor to a complex system development. But first, what is a regression? In a simplified way, it means that your product is not offering the same functionality as it did so far due to an unexpected effect of a change. Regressions can happen directly in the area a change is committed to, and in those cases will be likely caught by the targeted testing around this change. The more challenging regressions are happening somewhere else in the system though. Here's a simple example. Let's say your system is a car and the lights are controlled by an ECU receiving the driver input from the light switch by CAN. A message saying lights on or lights off, and the headlights switch accordingly. Now the developer of the UI is working on a new feature to turn on dome lights from the screen, and it's mistakenly using the same signal. So the UI dome light switch will switch the headlights as well as the dome lights, and the headlight switch will do that too. Sounds like a rather unlikely example? I've seen worse. So let's move over to testing. Both components will pass the feature testing. The light switch will turn the headlights on and off as expected, and the UI switch turns the dome lights on and off as expected. All tests passing on this level. Now, if you are running a waterfall-like integration approach, you will probably spend quite some time here at the component level testing out all the other features, maybe find a few issues, iterate around them, and eventually, after a while, hand your product over to the next higher level of integration. There might even be a few more levels before these two components, UI and headlight control ECU, meet, probably on the vehicle level. Now, the issue has been in your system for a long time, but has not surfaced yet. As you can easily anticipate, the UI switch will unintentionally control the dome lights as well as the headlights, and the same for the headlight switch. Finally, you catch this issue, and it is very close to the customer release, potentially weeks or months since it was introduced. Many other modifications, improvements, and development efforts might have been added to the product in the meantime. This example is a very simple one. Usually it is hard to pinpoint a regression that easily to a single origin right away because there are hundreds or even thousands of changes and commits between the culprit and the detection. So what does that mean in conclusion? It means that the switch to faster system development and to the continuous world has to involve early system integration testing in order to find regressions. That will naturally result in failing tests early on, so a mindset change is necessary as well to accept the fact that the test results will not be all green from the first run, and that is okay. It also means that the testing capability has to increase throughput several orders of magnitude in order to perform dozens or hundreds of system tests per release instead of only one. Of course, with growing test suites, this can easily become a challenge. A good strategy is to define a regression test suite that is not exhausting all performance and corner case tests, but define a high priority subset that gives you a quick feedback of general functionality provided by the system, and run that suite as often as possible, ideally with every iteration of the development. iProcess can help you to derive your custom integration and validation strategy, including regression test strategy. No matter if you start from scratch or you realize that your existing strategy is not supporting the agile development your company wants to switch to.